Here we go. So this is going to be 2.7 solve absolute value equations, right? And we're going to start with an example. We're going to pretend that we all are runners, and we're going to consider 3 scenarios, okay? The first one is going to be running exactly 3 miles, okay? Then there's going to be 3 scenarios that we're going to look into, okay? Let's do number 1. And the absolute value to represent the distance we're running. Remember that the absolute value function represents a distance. And we will be looking one-dimensional. We're going to be running either east or west. Sign numbers have 2 dimensions, direction sign and direction magnitude. So let's do the first one. No, this doesn't help much. Doesn't help. This does. Okay. So let's do the first one. The absolute value of 3 or the absolute value of 3 is equal to 3. And typically we write it as absolute value of x is equal to 3, where x is some unknown sign number. Okay. Then let me draw a number line. This is west and this is east. Okay. And this is home. So from here to here, it's going to be 3 miles. So in terms of miles, from here to here is what? 3 miles. And from here to here is 3 miles too. Okay? If we look at under the number line, we know that up to here is positive 3 and we have a negative 3. This is running exactly 3 miles in one dimension. So this is running exactly 3 miles in one dimension. So the absolute value of x, we're going to say that is equal to 3, right? So x is the direction and distance that I run. The direction and distance that I run. Okay? So there are going to be 2 solutions. And the 2 solutions are, one is going to be x equal to 3 or x equal to negative 3. When we have absolute value of x equal to 3. Now, So we could do these exercises. It's from it says activity 2.6, sheet 2. That's what it says. So let's try this exercise. It says solve. And the first one is absolute value of x equal to 8. So what do we so according to this, we know it's going to be equal to x is going to be equal to 8, or x is going to be equal to what? To negative 8. The next example, right? X plus 3 equal to 7. So we're going to have x plus 3 equals to 7, or x plus 3 equals to what? To negative 7, just like we did here. Now, what do I need to do? I need to make a 0. How do I make a 0? Oops, this is subtraction. By subtracting 3 on both sides. So what do I get? X is equal to 4, or x is equal to negative 10. And this is going to be my answer. Now, let's go to the next exercise. This one says x plus 1 is equal to 3. So we know x plus 1 is going to be equal to 3, or x plus 1 is going to be equal to negative 3. So what I need to do is make a 0. I'm going to make a 0, make a 0, and make a 0. So it's going to be x is going to be equal to 2, or x is going to be equal to negative 4. Absolute value of 2x minus 6 is equal to 6. So this is equal to 2x minus 1 equals to 6, or 2x minus 1 equals to negative 6. So again, I need to make a 0 first. So by adding 1. So it's 2x. I'm just going to do one side first. This is 7. Now we need to make a 1 by multiplying by the reciprocal. And what do I get? X is equal to 7 over 2, or let's do this one. 2x, and this is going to be negative 5. What do I need to do? Multiply by the reciprocal. So my answer is going to be x equal to negative 5 over 2. And the last one that I have here and the answer for this one is what? Remember, the empty set, or we do this. An absolute value cannot be a negative number. An absolute value cannot be a negative number. Okay? Now, when we have we get to the 1 through 6 exercises, which we just did it. Let's do this one too. I have 5x minus 3, that's the absolute value, plus 8 equals to 11. So one thing that we need to remember, we need to, the absolute value must be isolated before writing the compound sentence, okay? We need to isolate the absolute value. So what do I need to do here? I'm going to make a 0. So this is going to be 5x minus 3 equals to 3. Right here, I can write down the compound sentence. So it's going to be 5x minus 3 is equal to 3, or 5x minus 3 is equal to negative 3. We need to isolate the absolute value. The absolute value must be isolated, don't forget, okay? So now, right here, I'm going to make a 0 by adding 3 on both sides of the equation. So I have a 6. Now I'm going to multiply by the reciprocal because I need to work at 1. So this is going to be 6 over 5. One of my answers. Now let's go and try this one. I'm going to add 3 on both sides. I'm going to need to make a 0. So I get 5x equals to what? To 0. And I know, even if I multiply by the reciprocal, x is going to be equal to 0. And this is my answer. Okay? Now, let's do the next one that I have here. 7a. Yeah. Let's do the next one. 6, 7. So we have, trying to see if I have all of the more examples. So we have 2, 6 minus x over 4 absolute value equals to 10. All right. So what do I need to do? I need to isolate the absolute value. So I'm going to multiply by the reciprocal, right? 1 over 2 and 1 over 2. I'll write it down. So what I have here is 6 minus x over 4, absolute value. 10 divided by 2 is 5. So 1 is going to be 6 minus x equals to 5, or 6 minus x over 4 equals to negative 5. Now, what do I need to do? I need to multiply by the reciprocal on both sides. So this is going to be 6 minus x equals to 5 times 4 is 20. Now, I could make a 0 first or make a 1. So let's make a 0. And I'm going to have negative x equals 20 minus 6 is 14. Now, I know that what I have here is negative 1 over 1. So I'm going to multiply by the reciprocal. And this is going to be, x is going to be equal to negative 14. Now, let's go ahead and do this part. Right here, I need to do the same. I need to multiply by the reciprocal. So it's 6 minus 4 equals to negative 20. And going to make a 0 by subtracting 6. So it's going to be negative 26. So I'm going to multiply by the reciprocal. So x is going to be equal to 26. So those two are my answers. Now let's go and look at the example from the second scenario. Sorry for the noise. There we go. The second one will be running at most 3 miles. At most 3 miles. That's the second one. The first one was running exactly 3 miles, where we have the absolute value equal to 3, meaning x is equal to 3 or negative 3. Now we have running at most 3 miles. So to run at most 3 miles means to run less than or equal to 3 miles. To run less than or equal to 3 miles. And let's do the number 9. And it's going to be some distance between here, okay? Now, what we have here is absolute value of x is going to be less or equal to 3 miles. I'm running at most 3 miles. So this means what? That it's going to be greater or equal to negative 3, but less or equal to 3. From here to here, it's going to be greater or equal to negative 3, or less or equal to negative 3. Another way to write it is x greater or equal to -3 intersection with x less or equal to 3. Remember, when it's intersection, it's and. All right, so it's going to be, let me just show you, from -3 this way. And the other side would be and. All right, so the answer is going to be between -3 and 3. Now let me do an exercise. Right, let me do an example here. Um, hmm, let's solve this one. We have absolute value 2x minus 1 less or equal to 5. So remember that we need to isolate the variable first. Then just like absolute value equations, the absolute value inequalities is going to split into two different inequalities. And I'm going to write that down for you guys. Remember to isolate the absolute value, no, sorry, the absolute variable first. Okay, we do that first. Then just like absolute value equations, absolute value inequalities split into two different inequalities. Okay, so for example, what we have here is the running at least 3 miles. So remember, one equality, we have this. This is what we have. So one equality will be the original, okay? And the other equality is going to be what? It's going to be always the opposite of the original inequality and the opposite value. So we know this is going to be n. N. N is going to be the opposite of the other one, okay? So it's going to be greater and opposite value, negative a. Just like we did it here. You guys see that? One is the same and the other one is the opposite of the original and the opposite value. Let me write that down. This one is always going to be the opposite of the original inequality and the opposite value. Okay? So the first one will be the original and the other one is going to be the opposite. So now let's do this one. I had 2x minus 1. All right, so let's do it. So 1 is going to be 2x minus 1, just like the original. So one equality will be the original. All right, and the other one, oops, and the other one is going to be the opposite and opposite value. Okay, so let's get them. We're gonna add 1. I'm gonna make a 0 here. And what do I have? 2x is equal to 6. Now I'm going to make a 1 by multiplying by the reciprocal. So this is 6 divided by 2 is 3. Now let's go on to this one. Plus 1 plus 1, I'm making a 0. So it's going to be 2x is greater than negative 4. Now we're going to multiply by the reciprocal. We're making a 1. 4 divided by 2 is what? Negative 2. This is n, okay? Intersection. So what we have here, the numbers that are less or less or equal are going to be these ones. And the numbers that are going to be greater or equal to 2. All right. So I think I needed to do it separate. I don't know why I did it separate, okay? So this one is going to be less than 3, and the numbers that are greater than 2. So because it's n, it's an intersection. So where do they overlap? Right here. Where do I see two lines? Okay, so my answer is going to be from, I'm including -2, comma 3. We want an interval notation. All right, now let's do, I can do more exercises like this one, but I know we have, doing, let me do a couple more of these ones, okay? We're running at least 3 miles. So this is number 2. And let's see another one. This is greater. Let's do this one. 4, 3 minus x plus 1 less than 17. Okay. First, I need to isolate the variable, the absolute value. Okay, so that's the first thing that we need to do. So let's do that. I could either make a 1 or make a 0 first. Doesn't really matter. So let's do the, let's make a 0 first. That way we get that 1 on the other side. So this is going to be 17 minus 1 is 16. Now, let's make a 1 by multiplying by the reciprocal. So now we have 3 minus 1. 16 divided by 4 is 4. Now we're going to make our division. Remember what we said. We said it needed to be no wonder I couldn't find. So it's going to be, the first one is going to be the original and always the opposite of the original. Okay, so let's do that. So it's going to be this one, no absolute value anymore. Where did I get that x if it's a 1 there? And it's going to be, what did we say? The other one was going to be opposite, right? So it's going to be 3x opposite and the opposite value. Now, let's solve it. So what do we do here? Let's make a 1. So this is going to be negative x. This is going to be 1. And we're going to multiply by the reciprocal. So we have x less than negative 1. That's one answer on one side. Okay? And then on the other side, we're going to make a 0 here. So we have negative x greater than negative 7. And we're going to multiply by the reciprocal. Okay? So this is going to be x greater than 7. And remember, this is going to be n. So what do we have? We have a negative 1 and we have a 7. The numbers that are less than negative 1. Less than negative 1. Right? done. You know what? I should have changed. Right here, I need to change the sign because I'm dividing by negative number. Okay? And I'm gonna note it in a different color, that way you guys see it. All right? And the same is gonna happen here. So it's gonna be the numbers that are greater than -1. So it's not gonna be this way, it's gonna go this way. And the numbers that are less than 7. So my answer is going to be -1, 7. All right? Now, let's do the other scenario, which is we did running exactly 3 miles. We did running at most 3 miles. And now we're going to do at least 3 miles. Running at least 3 miles. So to run at least 3 miles means to run 3 or more miles. To run at least 3 miles means to run 3 or more miles. So if we do the number line, it's going to be so it's going to be what? Someone on this side and somewhere here. Okay, so greater than 3, at least 3 miles. So this means that we're going to have, or 1 is going to be greater than 3, which is the same one, and the other one is going to be what? Opposite and opposite value. This is going to be OR, which is union. It's when we squeeze the two lines together. Here says another way to write this is this way. U. So it's going to be this way. And this one is going to be this way. So it's going to be either this piece or this piece. Now let's try the exercises. So just like the absolute equations, there are 2 possibilities for the outcomes of each inequality. So one thing that we need to keep in mind is that unlike the absolute equations, we have to keep in mind that our solutions do not represent a single value, meaning distance, but represent many values. We can graph the solutions like we were doing here, like we just did it here, and we can also write them as a interval notation. And don't forget that when we solve for negative quantities, like this one, we always flip the sign. We will have to flip the sign, but we have a negative. But I'll show you more exercise, more examples. Here is another one right here. This one says 3x plus 1 absolute value greater than 4. Greater. So I'm going to use this one. I could go straight to do it because I don't have, it's isolated already in the absolute value. So one is going to be the same one, greater or equal to 4. The other one is going to be or, which is union, and it's going to be, the sign is going to change, opposite, and the number is going to be opposite value. Okay? So again, let me add the 1 here because I want to make a 0. 3x greater than 3. And now I'm going to make a 1 by multiplying by the reciprocal, and x is equal to 1. Let's do this one. We're gonna make a 0, sorry. So it's gonna be 3x less than 5. And we're going to make 1 here by multiplying by the reciprocal. 5 over 3. And this is going to be or. The numbers that are less or equal, and the numbers that are greater or equal to 1. All right, I do have another one here that we could do. Greater than 5. So let's do this too. We're going to find what do we need to do? We need to isolate the absolute value. So I'm going to make a 0 first by adding 1. It's going to be 6. Let's multiply by the reciprocal. We're making a 1. So this is going to be plus 4. 6 divided by 2. That's 3. There we go. Now, greater than, so we have x plus 4 greater than 3. Because we know it's greater than, it's going to be or. It's going to be a union. Don't forget that. So the next one is going to be opposite sign and opposite value. All right? Let's make a 0 here. X is going to be greater than -1. And this one, make a 0. X is going to be less than -7. Okay? And this is going to be our answer. And that's all I have for 2.7. For example, let me do another one here really quick. 2x minus 5 divided by 3 equals to negative 7. This is implicit. Absolute value can never be equal to a negative number. I think I did it already. Number. All right. This is it for 2.